Hi everyone, this is a video for Algebra Section 7 Part 2 Factorising Quadratics. So I usually do a little introduction section to my videos, however I've already filmed this part in Part 1. If you haven't already seen the Part 1 video then head to the description box below because I've linked it in there. Like I said in the Part 1 video, a quadratic equation looks like this: ax squared plus bx plus c. And when it's factorised, it looks like this. In Part 1, we went over how to factorise a quadratic when this a is equal to 1. In Part 2, we're going to go over how to factorise a quadratic where a is not 1. Now, there are different ways of remembering how this is done. I'm going to present the way that I do it. It may seem a little complex at first, but that's where practice comes in handy, which is why I always put together quite a few questions with every worksheet, which you'll see at the bottom of this page when we come to it. Alright, rules for factorising quadratics when the a here does not equal 1. If you're given a quadratic that looks like this and told to factorise, you'll know that when factorised it's going to look like this. However, you don't know what D, E, F and G are. To find D, E, F and G, you need to know these rules here. It might look like a lot of letters and quite a lot to remember. However, the way you get to these rules is really simple. You kind of work backwards. So here is a quadratic that's been factorised. If you expand these brackets, you get this expression here, which when simplified becomes this expression. Now this, it has an x squared term, it has an x term, and then it has a constant. Here, if we say df is equal to a, and dg plus ef is equal to b, and eg is equal to c, well then we get this quadratic here. So you can see how these rules occur. We've made df equal to a, that's rule 1, and it's happened here. We've made eg equal to c, so that's happened here, eg is equal to c, and we've made d times by g plus e times by f equal to b. So this expression here we've made equal to b. So you can see how these rules happen. It's good to remember them, but also it's good to know how they came about. So if you do forget it, you can always work it out. This might seem quite complicated at first, but as with everything, as soon as you get into an example, things start clicking into place. So let's look at some examples. Example 1, factorise 2x squared plus 7x plus 3. So we know what this expression is, it's a quadratic, and we know that when factorised it has to look like the following. Now we know from our rules here that d times by f must equal 2, e times by g must equal 3, and dg plus ef must equal 7. The next step is to look through some scenarios. Okay, if d times by f has to equal 2, then we could have the following. Also, if e times by g has to equal 3, then we could have the following. That's our first two rules satisfied. What about the third? We need dg plus ef to equal 7. Now on this diagram, multiplying the diagonals works out what dg and ef are. So for instance, if you multiplied this diagonal here, you are timesing e by f. Similarly here, if you multiply the numbers on this diagonal, you are working out what d times by g is. Let's do this diagonal first. Let's find out what d times by g is. D times by g, well that's 2 times by 1, which is 2. And we can write it down there. The next diagonal is this one. It's e times by f, which is 3 times by 1. So we have this number here. This number here is d times g, 2 times 1. And this number here is ef, 3 times by 1. This rule says that dg plus ef must equal 7. dg's here, it equals 2, and ef's here, and it equals 3. 3 plus 2 is 5. Therefore, we haven't satisfied this rule here. So this scenario doesn't work for us. Let's look at a second scenario. If d times by f has to equal 2, then we could have the following. Notice this is the same as scenario 1. If e times by g has to equal 3, then we could have this scenario. Notice how this is the opposite of scenario 1. That's our first two rules satisfied. What about the third? Again, we need to have dg plus ef equal to 7. So let's work out dg and ef. And remember, these are on the diagonals. So dg is this diagonal here, and ef is this diagonal here. So dg is 2 times by 3, which is 6. And ef is 1 times by 1, which is 1. And we need to have that dg plus ef equals 7. This is dg, it's 6. This is ef, it's 1. Therefore, dg plus ef is 6 plus 1, which is 7. Therefore, this scenario works for us. We've satisfied all three rules. Now we just have to write the answer. These diagrams are really nice because they help you work out what these letters are, but they're also presented in a way that shows you how the brackets in the factorised expression will look. These numbers are in the first bracket, and these numbers are in the second bracket. This is the answer. 2x squared plus 7x plus 3 is equal to bracketed 2x plus 1 times by bracketed x plus 3. As you can see, we have a 2 here, that's the 2 here. We have a 1 here, that's the 1 here. We have a 1 here, that's the 1 here. And we have a 3 there, that's the 3 there. So this is what I was saying, the diagram shows you how the factorised expression will look. As I said in part 1, it's always good to check your answer. So here, this is me checking to make sure I haven't messed up. I've taken the factorised expression, I've expanded the brackets, I've simplified, and I've checked that this quadratic here is equal to my original quadratic. Therefore, I know I've factorised properly. Let's have a look at example 2. Again, we have a quadratic, and we know that when we factorise a quadratic, it is going to look like the following. Bracketed dx plus e times by bracketed fx plus g. And we also know from our rules that d times by f must equal 3, e times by g must equal minus 8, and dg plus ef must equal minus 10. The next thing to do is look at some scenarios. Scenario 1. We know that df must equal 3, so how about we have 1 and 3? We also know that eg must equal minus 8, so what about this? Minus 1 and 8. So we've satisfied our first two rules. What about the third? We need to have dg plus ef is equal to minus 10. Remember, dg can be worked out multiplying the numbers on this diagonal, and ef can be worked out multiplying the numbers on this diagonal. So dg is 1 times 8, which is 8, and ef is minus 1 times by 3, which is minus 3. And we need to have dg plus ef is equal to minus 10, i.e. we need to have these two numbers adding up to minus 10. Now we have minus 3 plus 8, which is 5. Therefore, we haven't satisfied this final rule. So this scenario doesn't work for us. Scenario 2. Again, we're going to keep this the same as scenario 1. It's always good to keep one thing fixed, and I generally keep d and f fixed. D times by f is 3. Now e and g must equal minus 8. Looking at scenario 1, let's try it swapped round. Therefore, we have minus 8 and 1. So we've satisfied our first two rules. What about the third one? It's time to do the diagonals. D times by g is 1 times by 1, which is 1. And we'll write that there. E times by f is minus 8 times by 3, which is minus 24. Now, like we said, these two numbers have to add up to give minus 10. However, they don't. So this scenario doesn't work for us either. Third scenario, again, we'll keep d and f the same. So we have 1 and 3. Now for e and g, let's try minus 2 and 4. Minus 2 times by 4 still gives minus 8. So we've satisfied the first two rules still. Now the third rule. D times by g is 1 times by 4, which is 4. And e times by f is minus 2 times by 3, which is minus 6. These two numbers need to add up to give minus 10. Minus 6 plus 4 is minus 2. Therefore, this scenario doesn't work for us either. Final scenario. D and f is still the same, but e and g we're going to try as minus 4 and 2, we've satisfied the first two rules. Now for the final one. D times by G is 1 times by 2, which is 2. And E times by F is minus 4 times by 3, which is minus 12. Minus 12 plus 2 is minus 10. Well, this is exactly what we needed. This satisfies our third rule. Therefore, this scenario works for us. Once again, we can use this diagram to see what our factorised expression will look like. The first bracket will be x minus 4, and the second bracket will be 3x plus 2. There we go. I know I always bang on about it, but it's good to do a check. I've taken the factorised expression and I've expanded the brackets to give this. I've then simplified to get this quadratic here. This quadratic is the same as this original quadratic, therefore I know I've factorised correctly. Let's take a look at the final example. Again, we have a quadratic, and we know when we factorise a quadratic, it's going to look like the following. Now you know the drill, we've got to look through some scenarios. I'm not going to go through every step now, I'm just going to show what D and F and E and G are straight up. So scenario 1, D is minus 1 and F is 2. We've satisfied our first two rules because here D and F times us to give minus 2 and E and G times us together to give 6. Now we just need to check our third rule. DG is minus 6 and EF is 2. 2 minus 6 is minus 4. Scenario 2, we've got DF equaling minus 2, EG still equaling 6, so our first two rules hold. We've got DG equaling minus 1 and EF equaling 12. 12 minus 1 is 11, therefore we haven't satisfied our third rule. DF is equal to minus 2 and EG is equal to 6, therefore our first two rules still hold. DG is equal to minus 3 and EF is equal to 4. 4 minus 3 is 1. We're nearly there, but we haven't quite satisfied this third rule. Final scenario, DF is still equal to minus 2 and EG is still equal to 6. Remember, a minus times by a minus is a plus, so this here equals 6. So we're still satisfying our first two rules. What about the third? DG is equal to 3 and EF is equal to minus 4. Minus 4 plus 3 is minus 1. Thank God. Right, we've satisfied our third rule. Again, from the diagram, we can see what our brackets look like. And here we have it. Bracketed minus x minus 2 times by bracketed 2x minus 3. Right, this is a good point to probably pause the video, try out these questions, and then come back to the video and check your answers and workings to mine.